Here we are in section 1.3 with the solutions to numbers 14 through 22. Notice here it says use the formulas in this section. We are in section 1-3, so we're going to head over to the textbook and here's section 1-3, all the variables and formulas. Now, we did substitution. Here are the common formulas. Distance equals rate times time. Tax, rate times the original price or the principal amount. If you are increasing or decreasing, you have very similar formulas there. Compounded interest, temperature conversions, money value. Oh, look, all the geometry units and then the geometry formulas. So when I pop out a formula, it is in reference to these pages. They are also found at the end of the textbook for good reference. So you can find them in the appendix as well, but that's what it means when it says go to this section in the textbook, is section 1-3 in the textbook. So distance, we have rate times time equals distance. And using pi, I should finish the instructions. Find the missing variable. So in this case, we're trying to find d. It says, note, if you don't use the pi button on your calculator, your answer will differ slightly than what's in the book. So yes, rate times time equals distance. So we take 75 here, 75 times 5, and to find d. So we get 75 times 5 is 375 miles. Notice when we take miles per hour and we times it by the number of hours, the hours cancel and we're left with miles. So 375 miles. All right, the next one, tax. This one was simply tax equals the rate times the original price. So we're going to take 0.06 times 29.95, and this is in dollars. So let's pull out our calculator and say 6% times 29.95, enter, and we get 179, 1.80 if we round to the nearest cent. All right, discount. Ooh, now remember this one was P minus RP equals F. Yeah, so 48 minus 30%, that's 0.3 times 48 equals the final price. And notice what's happening here. This is two problems in one. This is 30% of 48, which is how much money you save, subtracted from the original 48 will give you your final price. So 48 minus 0.3 times 48 is 33.6. So that'd be $33.60. So if you had something at $48 and had a 30% discount, that's what you would end up paying. Notice that this is also the same as we could have done by the distributive property. This is the same thing. And that's just 0.7 times 48. All right, number 17, compound interest. So this is where we're going to take A equals P 1 plus R over N all to the NY. That's the formula that comes out of the book. So we're going to write down A equals 2,500 times 1 plus 0.035 over 12 all to the 12 times 12. That's a 144 up there. Let's punch this out and punch it in. Let's double check that we punched in right. 2,500 times 1 plus 0.035 divided by 12 all to the 144th power, 3802. And make sure you remember that that is in dollars and cents, 3802. Oops, no decimal there, 3802 point, and that was 58 cents. Alrighty, temperature conversion. We're looking for C, so C is 5/9 F minus 32. That's what comes out of the book. So that formula, 88 goes right in there. 88 minus 32 is 56. So we get 5/9 times 56. Let's go ahead and punch this out. 5/9 times 56. 5 divided by 9 times 56. Enter. 31.1. So that's 31.1, repeater, if you would like to, degrees Celsius. Make sure these units are on there. All right. Now if we're going the other way, the formula is F equals 9/5 c plus 32 without parentheses. So this negative 12 goes right in here. So we get f equals negative 9/5 times a negative 12. Ooh, oh, not a negative 9/5. What is that doing out there? 9/5 times a negative 12 plus 32. Let's punch that in, see what we get. 9 divided by 5 times negative 12 plus 32, and we get 10.4. So that's going to be 10.4 degrees Fahrenheit. Yeah, negative 12 Celsius is 10.4 degrees Fahrenheit. Bingo. Number 20. Let me see, what are we looking for in a triangle? Area is what we're looking for. Area is 1/2 base times height. So we've got to take 1/2. The base is 4. The height is 7. So 1/2 times 4 is 2 times 7 is 14. Notice we're in area, so this is inches squared. 14 inches squared. Good. Number 21. For a parallelogram. Oh boy. Are we trying to find area? No, we're trying to find perimeter. Now the perimeter on a parallelogram, you may have to look that one up. Go ahead and take a minute and make sure you've got the formula there. And when you have A's and B's, the formula came out and it had something like this, where this is an A and the B side, and then it also had a height, and the height was used in formulating the area, but we're looking for perimeter, which was just 2A plus 2B. Yeah, that's it. Perimeter just is adding up around, so that it's an A and an A and a B and a B. Oh, good. So we don't even need the height. That's important to note, that in the formula for perimeter, height is not necessary. So 2 times 5.1 plus 2 times 4.9. Punch that in, you get 20. And this is in, perimeter is just a one-dimensional distance, so this is 20 meters. Alrighty. And the last one on this section, for a trapezoid. Now a trapezoid, we're looking for area, so we've got to find the area formula, not the perimeter, and it is 1/2 h, the big base plus the little base. So that is 1/2 times the height, which is 5, times the big base, which is 9, plus 7.8. This is 1/2 times 5 times 16.8. I'm going to punch that in. 0.5 times 5 times 16.8. What does that enter? 42. Now, are we in, what dimension are we in? 42 what? This equals 42. Is it feet? Feet squared. This is an area. It's second dimension, and it is feet squared. Areas will always have a little 2 on their units. Excellent.